All right, hi everyone. Sorry for the slight delay. Actually, I was having some technical issue. My software configuration was giving me some trouble. So, hello Shiva, how are you? Finally, I am here. Finally, I have got the settings right. Okay. So, first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT And on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 11 students. Today, we are going to start a new topic, which is fluid mechanics. This is lecture number one, and today we'll be talking about fluid statics. Now, before we go ahead with today's lecture, let me introduce myself for those of you who don't know me yet. So, my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, all of this teaching so far had been on offline setups, and as a student, I myself was All India Rank 447 and All India Rank 192 in the two stages of the IIT exams that I took. Now, I also qualified the NTSC Stage 2 as a student, and I was in the top 1% in the NSEP as well. Now, in those offline setups, I have already coached many students to top ranks in the IIT examinations, and now I hope to continue doing that here off online with you guys. All right. So, yes, Shiva, hi. So tell me, how can I help you? What is it that has been bothering you? Tell me. Sir, approximately how many lectures will it take to complete this chapter? Okay, so for this chapter, we will take at least 6 to 8 lectures. Okay, so let's say at least three lectures for fluid statics, 3 to 4 lectures for statics, and let's say another couple of lectures at least for dynamics. Okay, and then we will take at least 3 lectures for surface tension and viscosity. Okay, so let's say 6 to 8 lectures. Hi Shivpal Singh, how are you? Okay, so again, moving forward, as I told you, this year I had to adapt. Just in the last year, all of us had to adapt because of the new situation. So when students also have another chance of making sure that their studies are going uninterrupted, and that is by getting yourselves the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. Then you have live polls and leaderboards in these classrooms. You also have test series and analysis sessions, and of course, you have live doubt clearing sessions. So that is, I think, one of the most wonderful features of all Unacademy subscriptions. That every Unacademy Plus course has to have a live doubt clearing sessions after every 3 teaching sessions. So every fourth session is a live doubt clearing session. Okay. So after every 3 teaching sessions, you can have an entire session dedicated to your doubts where you can ask away anything that you have in your head, be it about the concept, be it about problem solving, so that your doubts never get piled up. Now, along with all these benefits, an academic subscription also allows you to study from the topmost educators all across the country from the comfort of and safety of your home. And I think it's a wonderful opportunity. Okay. Now, if you want to utilize this, then this is how you need to go about it. The first step is to install the Unacademy app. Now, the moment you do that, you unlock yourself a lot of free features. So, when you install this app, you will realize that there are a lot of free courses that are running. Okay, so anybody who has this app installed can enroll in these courses without having to buy the subscription, and then you can attend special classes. So there are special classes that different teachers keep taking on a regular basis, including myself. So we will take at least I take around 3 special classes every week. So those are completely free, and anybody who has just installed the app can enroll in those also, and then you can take part in quizzes also. So there are a lot of quizzes that we have, something like what we conduct every Tuesday. So just by installing the Unacademy app, you can unlock all these free features using the code RD Live. So you can use the code RD Live and unlock all these free features and already get benefits out of this Unacademy app. Okay. Now, when you've attended all those classes, when you have got yourself a flavor of how your plus subscription is going to be, and if you finally take the call of buying the plus subscription, this is how you go ahead with that. Now you can go to the plus section of your app, select your goal as IIT and click on that get subscription button. The moment you do that, you will be redirected to the payment page where you can use the code RD Live. So you will find a box here which will say, do you have a code? So that is where you can put this code RD Live and get yourself the subscription. Now you can choose from two kinds of subscriptions, Plus or Iconic. Plus is your regular subscription, which unlocks all the benefits of your Unacademy Plus app. Okay, now Iconic is something extra. Okay, so we'll talk about that in a bit. Now let me just quickly tell you that the fees of these subscriptions is kept very moderate. So 12 months subscription roughly comes to about 2,800 a month, and 24 months subscription comes to about 2,100 a month. So at these prices, the kind of quality content that you're getting, the kind of features that you get to learn from, I think the opportunity that you're getting for these prices, it's completely worth having. So in my opinion, this subscription is a must-have. Now, when you click on proceed to pay, you will also realize that you have a lot of no-cost EMI options to make these payments so that you never feel the burden or pinch of these payments. Okay. Now, talking about the Iconic subscription, this subscription will take your JEE preparation to the next level. How does it do that? You will be allotted personal coaches. Okay. So those personal coaches will closely guide you and mentor you throughout your IIT JEE journey. So you'll be getting more individual attention, let's say, and you will obviously have regular IIT JEE workshops. You will be receiving timely expert guidelines. You will be getting a study planner, and you are having regular test analysis sessions. So with all these extra features, apart from your plus benefits, and with the help of these personal coaches, definitely your preparation would spearhead ahead. Okay, so this is mainly meant for those who want a more individual attention, or so everybody has different approaches to a study. So some of us like to have more personalized guidance and individual attention. So those of you who want that can go for this subscription. Now you can also go for combo subscriptions. So there are combos of 11, 12 CBSC plus your IIT JEE preparation. So you can go for there are many combos. So first combination is this. So where you get the Iconic IIT JEE subscription and the plus CBSC 11th and 12th subscriptions. Then you can get all three Iconic as a combo. Then you can get all three plus as a combo, or IIT JEE plus and 11th 12th Iconic as a combo. So these are the combo subscriptions that you can go for. Okay, so in case you are looking for a complete preparation for your 11th 12th and your IIT JEE, go for these. Next, you can also win yourself these subscriptions, test your knowledge, and see your standing amongst your peers by taking part in the Unacademy Combat. This, if you don't know, is the most competitive gamified IIT JEE battle. Okay, you can compete live, and if you do well, you stand a chance to win yourself really cool prizes and rewards. So the next Unacademy Combat is going to happen on the 17th of Jan. Okay, you can enroll now using the code RD Live. You can take part in it. If you do well, you can win yourself some really cool prizes. Now, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link, so that you're receiving all the timely notifications of all the lectures and sessions that are happening here on this channel, that you're not missing out on any of this amazing content. All right, so let's get started with today's topic finally. Today, as I said, we'll start our discussion with fluid mechanics. Okay, and today we'll be talking mainly about fluid statics. So let me just tell you about fluids first of all. So what is fluids? So any substance that deforms continuously under the application of a shear or tangential stress, no matter how small that shear stress is what we call a fluid. Now, those of you who don't know what shear stress is, so in your topic of solids, when you will study, you talk about forces that try to change the shape or size of the object. Okay, so those can be categorized in these following conditions. So let's say you have a body and you have such kind of forces. Okay, so this kind of force will try to change the size, right? It will try to increase the size of the object. So this one is called tensile. The internal resistance, the internal forces that are developed due to this are called tensile stresses. Okay, then you could have had this kind of force, right? This would have tried to compress the body. Okay, so these are all the forces that can produce different stresses. So this is compressive stress. Okay, then you may have another kind of a force which will try to just change the shape of the body. this. So these kind of forces, these are called shear forces. Okay. Forces that try to change the shapes of the bodies are called shear forces. So that is what we are talking about here. That fluid is any substance which cannot withstand any even small amount of shear stress. So let's take up an example to see that. So imagine I have this solid with me, and if I try to deform its shape, okay, now this is holding its shape, okay, this is not getting deformed. So that is why this kind of a solid has a definite shape and size, right? Now it does not change its shape easily. It does not even change its size easily. Even if I try to compress it, its size is not changing very easily. So that is why solids can hold a definite shape and a definite size. However, how about fluids? So let's try and take up an example here. Okay. So let's imagine I am filling up water in a glass. Okay. So now imagine this. Now the moment I tilt the glass, what happens is that gravity would have, if this glass, if the fluid did not tilt, then the fluid, imagine, remained like this. Then the force of gravity would have pulled it like this. So you realize the water comes over here and this will remain flat. So this, you can see, does not hold any fixed shape. Okay, the shape here is this part of the glass. The shape here is this part of the glass. The shape here is slightly different. The shape like this would be slightly different. So a liquid can never hold a perfect shape or a fixed shape. Why? Because any amount of even negligible shearing stress or negligible force of deformation will cause it to change its shape. Okay, so that is how you define fluids. That is the technical definition of fluids. Okay, so remember this: a substance that deforms continuously under the application of a shear stress, no matter how small. Even for a negligible shearing stress, it should go and have a continuous deformation. Now, even some solids will show some deformation, but that deformation stops eventually. Okay, so for instance, let's take up another example. Okay, so imagine I have a wire like this. Now, if I try to change its shape, if I have a force, then it does change its shape till an extent and then it stops. It does not go on bending. Okay, if I don't increase the shape. The fluids and liquids are synonymous. No, they are not. No, they are not. No, they are not, Shiva. See, fluids would be anything that cannot hold a shape or size. So fluid in general would be liquids plus gases, right? Even gases cannot have a fixed shape. In general, that is what we can call fluids. Okay. There can be other fluid substances also. All right. So again, as I was showing you the deformation here, if I apply a small amount of force, then you realize it does undergo a small amount of deformation and then it stops, right? It does not go on deforming. On the other hand, if this was a liquid and if a liquid surface was tried to deform, it would have continuously gotten deformed till the time the force would have acted. Okay, so that's the difference between solids and fluids. Again, all right. Now, as I said, as a result of the above property, these fluids have no fixed shapes. So that is how you can identify any fluid. Okay, Shiva, anything that cannot hold a specific, a fixed shape is definitely a fluid. Okay. Now, in our studies, we will focus only on ideal liquids. So first of all, as I said, since in general your fluids will contain liquids and gases, so first we will mostly focus on liquids in the part of fluid statics. We will be focusing on liquids, and that too we will be focusing on ideal liquids. Okay, so what are ideal liquids? Now, liquids can also be divided into two categories, right? You can divide these into ideal and real. Now, we will, in order to simplify our study and approach, we will only deal with ideal fluids. So, ideal fluids have the following properties: that they are incompressible and they are non-viscous in nature. So we ignore their friction between two layers of fluid, which is called viscosity. We will talk about that later. And we assume that our liquids are incompressible, means unlike gases, their volumes cannot be changed. Okay, that is what incompressible would mean. That volume cannot be changed. You can change the shape, okay, but volume, total volume cannot be changed for ideal liquids. Okay, so that is a property of an ideal liquid. Now, again, even when I'm studying liquids, I will divide that study into two parts. Okay, one is called fluid statics, and another is called fluid dynamics. Again, fluid statics refers to the study of fluids at rest, and fluid dynamics refers to study of fluids in motion. Okay, again, the study is divided into two parts because of slight difference in the behavior of a fluid when it is at rest and when it is moving. Okay, so first part that we'll be covering right now is again. So when we talk about fluids, there are two kinds of fluids generally: liquids and gases. First, we will focus only on liquids. That too, in liquids also, we will focus only on ideal, and then we will divide the study of ideal liquids also in two parts: statics and dynamics. And right now, we will start with fluid statics. Okay, hi Shivam, how are you? Next, so let's talk about characteristics of a fluid. Now, since a fluid does not have a definite shape, however, it does have a definite mass and a definite volume, right? So mass and volumes will be definite for any liquid. So any liquid can be characterized by its density. Okay, so density is a peculiar quantity related to any liquid. Okay, for instance, density of water is always one. Okay, similarly, density of any oil, let's say petrol, would be always one. So any liquid that is an ideal liquid that is incompressible. So we assume that the volume cannot be changed. Okay, so if a liquid is an ideal liquid, then it has a fixed density, okay, which is essentially depending on its own properties, okay, how the molecules are arranged inside it. Okay, so that is what we use to characterize any fluid, okay. Now, density of any substance, obviously, as you know, is defined as mass per unit volume, right? The standard symbol is usually rho, and of course, the units would be kg per meter cube. That would be the SI unit, right? Now, for an incompressible liquid, obviously, the density is constant, and a density of a liquid is sometimes expressed as the ratio with the density of water at 4 degrees Celsius. So, again, your densities do change with temperature. Okay, your densities do change with temperature. So, don't think even for incompressible liquids. At a fixed temperature, you cannot change their density, but by changing the temperature, the density can be changed. So Shivam says that I'm giving Sunday tests regularly, but I'm observing continuous decrease in my performance. I do 1 hour analysis after the test, but my marks are decreasing day by day. What should I do? Okay, okay. So what you can do is, Shivam, come to the next doubt clearing session of. You come, let's say tomorrow or day after tomorrow. Okay, we have two doubt clearing sessions on Plus. Okay, so you can come there. Let's say I will give you a problem and you tell me the approach, and I will try to see where you're going wrong. Okay, and you can also share your analysis, whatever analysis you did on your test. You can share that analysis with me and I'll try to help you through it. Okay, all right. So again, either I can tell you about the density as mass per unit volume. This is called the absolute density. Okay, or sometimes what you do is you tell the density, relative density, which is density of the substance over density of some other reference liquid. That is called a relative density. Okay. These are usual two methods of specifying densities. Yes, you do that. You do that. Okay. Okay. You come to the doubt class tomorrow and do that. Okay. Don't worry about it. We will go through it. So, how to find density of gases? Okay. So, gases do not have very fixed densities, right? Because they can occupy any space that you put them in. So they don't have a fixed density. Their density depends on the amount of volume that they are. Again, the definition of density would be same, mass over volume only. But no gas has a fixed density. For instance, the density of water is fixed, right? The density of water at 4 degrees Celsius is fixed. Similarly, the density of gas is not fixed. You can take one amount of gas and change the volume of the container that it is in. Then the volume of the gas will change, right? So let's say, for an instance, take two containers. Let's take two containers, okay? Imagine one of them has a liquid like this, okay, and the other one has a gas. Okay. Now, what you will realize is that if I pull the boundaries up, if I make the container longer, okay, imagine if the boundaries were movable for density of gases, for volume, we have to take the volume of container. Yes, absolutely. Because that is the problem with gases. Gases will occupy the entire volume available to them. However, that is not the case with ideal liquids. Ideal liquids, you will see the volume is constant. V is constant. And for gases, V equals volume of container. Right? So for gases, density is not a fixed characteristic. It is not a fixed characteristic with which you can identify a gas. Okay, if I tell you a liquid has this density, you can narrow it down. Okay, so this must be this kind of liquid. If I tell you the density of a liquid is 1, you can imagine, okay, it can be water. Okay, however, that's not the case with gases. Okay, I hope you understood that. That is why liquids can have definite densities, but the gases do not. Yes, yes, yes. That we will talk about in thermodynamics. That we will talk about in thermodynamics. But in general, that is how you calculate it. You take the mass enclosed. If m is the mass enclosed, m over volume of the container. Okay. We will talk about the formula later. All right. So as I said, for an incompressible liquid, the density is constant. Now, this is a relative density. So relative density can be defined with respect to any substance. Okay, so if you have let's say two liquids, let's say you had some kind of an oil, let's say cooking oil you had, okay, and then let's talk about another liquid. Let's say you had petrol. Okay, so relative density of oil with respect to petrol would be the ratio of density of oil to density of petrol. This is how you find the relative density. With respect to a particular reference liquid, what is the density of the liquid that I am studying? Now, if I take the reference liquid as water, then it is also called specific gravity. Okay. Or sometimes we only tend to mean it with respect to water only. Okay. So please note, specific gravity is a special kind of relative density when the relative density is specified with respect to water's density. Okay, then that is called specific gravity. Yes, Shivam, what happened? Is the voice not clear? Tell me, is there any issue with the voice? So yeah, I'm not I'm not feeling very well. So that is why maybe my voice is a little sticky. Okay. Okay. All right. Okay. As I said, when relative density is specified with respect to water, then it is called specific gravity. So specific gravity is a special term when you are specifying the density of any liquid with respect to the density of water. Okay. Now, density does vary with temperature. Again, we will study about this in detail when we are discussing thermodynamics. But this is just for you to know that as the temperature of a liquid is increased, obviously what happens is we know that thermal expansion will happen. Whenever things are heated, they expand, right? So we will talk about this in detail when we are discussing thermodynamics. But right now, you should know that the mass remains the same. while the volume increases. Now, if the mass is remaining same and the volume is increasing, what happens to the density? Density would have decreased. Okay, and the new density is given as this, where rho dash is the new density. Rho dash is new density after increase in temperature. Okay, and rho is the original density before you increase the temperature, right? Gamma is called the coefficient of thermal expansion, and delta T is the rise in temperature. Okay, so this is how you can find the new density also. Now, gamma is another characteristic of any liquid, or for that matter, for every substance. You have a fixed thing, a constant, which is called the coefficient of volume expansion. So that relates the change in volume with respect to change in temperature. Okay, so gamma is a fixed constant property of the substance. Okay, please remember. So fixed for one substance. For instance, for water you will have one gamma. For oil you will have another gamma. For petrol you can have another gamma. The original density means at what temperature, sir? Depends. Let's say you are initially having at 20 degrees Celsius, and you are increasing the temperature from 20 to 50. So rho would be the density here, and rho dash would be the density here. Final density is rho dash. When you started, then the density was rho. Okay, so that is how you do it. Okay, original density means before you started increasing the temperature. So this is relating, this formula basically relates the density before temperature rise and the density after the temperature rise. Okay, I hope that is clear. And of course here delta t in this case would have been 30 degrees. Okay, and a gamma would be the fixed constant for that material. Okay, I hope that is clear. Hello Raj, how are you? Okay, again we will discuss this in detail when we talk about thermodynamics. Right now you should just know this formula just in case you encounter such a question. Just memorize this formula for now. Okay, we will derive this, we will study this in detail in thermodynamics. Right now, if by chance you encounter a question, you should just memorize this, and you should know that whenever the temperature is increased, the density decreases. Okay. Now, densities can also change with external pressure for not for compressible liquids. Again, this is only for compressible liquids. For incompressible liquids, you cannot compress and change their densities. So for most of our substances, if you compress them, if you apply external pressure, then their volume decreases. If their volume decreases, then that would cause an increase in the density, right? Now, the increase in density can be related to the increase in pressure like this by this equation. Again, this is studied in the topic solids. Okay, hi Mahi, how are you? Okay. So those of you who don't know this delta rho is the increase in density. Rho was the initial density before you increase the pressure. dP or delta P is the increase in pressure, and B again is called the coefficient of bulk expansion. Beta or B is constant, and it is called coefficient of bulk expansion. Okay. So this term relates the change in volume with change in pressure. Okay, so if you increase the pressure, then this is how your densities would change. Now, for ideal liquid, this can be considered to be infinite, so they will be incompressible. Their pressures cannot be, their densities cannot be changed no matter how much you increase the pressure or you decrease the pressure. Okay, now in general for real, so this equation valid only for real gases, real liquids. Okay, because only they will show this behavior, or in other words, you can say for ideal liquids, I can consider that the bulk coefficient of bulk expansion is infinite. So they do not respond to any pressure change. Okay, for ideal liquids, there is no density change seen for a pressure change. Again, since we are focusing only on that, so we will tend to ignore this. Okay, but just in case, if a question is asked, you should memorize this formula. Okay, we generally do not use this very often. All right, now another very interesting characteristic of any fluid is pressure. It always exerts a pressure. So the way you define the pressure is the force exerted per a unit area. Okay. Now, for any fluid at rest, it exerts a force perpendicular to any surface in contact with it. Okay, this perpendicular force per unit area is what we define as pressure applied by the fluid. Now, why does this happen? Let's talk about that a bit. You would realize what happens is even if you take any sample of a liquid. Okay, so let's consider I have this container in which I have some liquid. So imagine I have some liquid in this. Now, turns out if you study these liquid molecules closely, if you study these liquid molecules closely, then turns out all the molecules of this liquid are constantly moving around here and there. So these molecules are constantly moving in all random directions. Okay, again, completely random directions. So somebody might be going one way and the other might be going the other way, and so on. So it turns out in a liquid also the molecules are constantly moving in random directions. Okay, so because of that, what happens is that just write that down first. So I will realize in liquids. So in case of solids, you realize the molecules are always fixed at their positions. Okay, all the molecules are always fixed at their positions. They do not change their position. For instance, let's talk about this. Okay, let's talk about this. So here you realize a molecule that is here will stay here forever. It will never change its position. A molecule that is here will stay here. It will never change its position. And in liquids, that is not what is happening. So in liquids, all molecules randomly move in all directions. Okay. Now that is what happens when you talk about diffusion. Okay, imagine if I dropped a color here, if I dropped a color here, you realize that color would have just stayed here. That color would not have spread all across in the solid, right? However, if I take a liquid and I put a drop of color at one point, you realize after a bit it will actually spread throughout the liquid, right? That is happening because these molecules are constantly moving. So if the color molecules are sticking to one or spreading in one space, because of these molecules, they will spread all around. Because of these randomly moving molecules, they will take those molecules all around, and that is what causes diffusion. Diffusion is the phenomenon that you see in your liquids and gases, right? That is happening because of these random motion of all the molecules. Now, because these are moving in every direction, so what will happen is if I keep a plate, so if imagine I keep a surface of solid here inside this liquid, what happens is that some molecules will collide with it, and after colliding, they will bounce off. Okay, so that is what is happening. If you insert a surface inside the liquid, you realize that a lot of molecules which were moving towards it will collide with it and bounce off. Okay, now that is what is causing that pressure to be exerted. Okay. Now, obviously, you will realize that the total amount of force would have depended on how large the surface I have chosen. Because the larger the surface, the more would be the number of molecules colliding on it. But if I define the force per unit area, then that is the property of the liquid. That is telling you per unit area how many molecules are colliding, with what velocity they are colliding, and per unit area, if I defined it, that becomes a property of liquid. Okay, that is why with liquids we associate pressure and not force. Force is a property of the surface which you are keeping. Okay, the larger the surface, the more would be the force that it will feel. But the force per unit area depends on the properties of liquids. So that is why pressure is a characteristic of a liquid or gas also for that matter. Okay, so I can say due to this motion, due to this motion, when a surface, when a solid surface is submerged in a liquid, it experiences a force. Okay, that force is due to collisions of these molecules with the surface. Okay, I hope that is clear to all. Okay, what I just said. Okay, so let's go over this point once. So I said in liquid, a lot of molecules are randomly moving from here to here. So whenever you insert a solid surface, then there will be collisions of the solid surface. Some molecule might be moving here, will collide and bounce off. Some molecule might be coming directly and coming and bouncing off. Some molecule would be coming from there and bouncing off. So there will be a lot of molecules that will go and collide against that surface, and in that process of collision, they end up exerting a force. Okay. Now, what you will realize is that obviously that force of collision, because it is rebounding, so the force is normal reaction, right? So that is why this pressure exerted is always normal to the surface. Okay. So that is another interesting thing. This force, this force exerted is always perpendicular to the surface. So that's another interesting thing that you will notice. If you keep your surface oriented like this inside the liquid, then the forces would be exerted like this. If you change the orientation, if you kept the surface like this, then the force would be exerted like this. If you kept it like this, then the force would be exerted like this. But in all orientations, the force will always remain perpendicular to the surface. Okay. I hope you realize. Now pressure now is defined as the force experienced per unit area of the surface. Okay. So I can say the force experienced per unit surface by the solid is called the pressure exerted by the liquid. Okay. Okay. I hope that is clear. Okay. So that is how you define the pressure exerted by a liquid. For that matter, you could have had a pressure exerted by gas also. Okay. It works the same way. Okay. So that is the entire reason of that pressure being exerted on any surface that is being submerged in a liquid. Okay. All right. So let's go back to the previous page. So as I said, the pressure is defined as the force per unit area, right? This is how you will measure the force per unit area. Now, obviously, the SI unit would have been Newton per meter square, but we give that a special name. SI unit is pascals. Okay, and 1 pascal equals 1 Newton over 1 meter square. Okay, so that's the SI unit of pressure. Okay, we give it a special name. We're calling it Pascal. All right. Moving forward, let's talk about pressure a little more. Now, when you are in a fluid pressure, so first I've already told you this, that fluid pressure always acts perpendicular to any surface, no matter how the surface is oriented. So you could have kept your surface like this, kept your surface like this, kept your surface like this. The pressure or the force exerted would have been always perpendicular to the surface. Okay. Now, hence pressure in itself has no intrinsic direction. So please note, hence pressure has a no intrinsic direction on its own. And that is why it is a scalar quantity. Okay, it's a scalar quantity. By contrast, where force is the vector, so force per unit area is a scalar quantity because it has no intrinsic direction of its own. Now you can define pressure in two ways. When you are specifying pressure, you can specify it in two ways. You can either specify the absolute pressure, so force per unit area. If that is what you're reporting, this is called absolute pressure. Okay, where you are actually telling this is the force that the liquid is exerting per unit area. Now you can also talk about gauge pressure. So gauge pressure is defined as the pressure in excess of the atmosphere. Okay, the excess pressure above the atmospheric pressure is usually called gauge pressure. Now the total pressure is called the absolute pressure. Now gauge pressure and absolute pressure can be related like this, right? So gauge pressure would be absolute pressure minus atmospheric pressure. Okay, pressure in excess of the atmospheric pressure. So how much more pressure is something applying more than the atmospheric pressure? That is called gauge pressure. Now you will notice one thing, that your absolute pressure can never be negative. Okay, because whatever collisions are happening, they will always exert a push only force. Okay, so pressure is meant for a push only force. Okay, please remember that. And you will notice that absolute pressure can never be negative. Negative would have meant a pull kind of force, right? And never be negative. Please note that. Okay, your absolute pressure is always positive. Your liquid will always push any surface which is kept in contact with it. Okay. Now, how about the gauge pressure? However, gauge pressure can be your gauge pressure can be positive, negative, or zero. Okay, so gauge pressures can be positive, negative, and zero. However, absolute pressure is always positive. Remember that. Okay. All right. Now let's talk about the variation of pressure with depth. So at any depth h from the surface of the liquid, you have the gauge pressure as rho gh, and hence absolute pressure can be written as P naught plus rho gh, where P naught is the pressure of atmosphere or the external pressure. Okay. Now please note that this formula is true when no other external forces are acting on the liquid except the force of gravity. Okay, so how do you get this? Let's try and prove that. Okay, let's try and figure out how the pressure would vary. Okay, so again, going to add another page here. Or do I have? Okay, so this is another thing. So first, let's talk about how I can find the variation of pressure with the depth. Okay, what I do is, so I will imagine again a container. Okay, let's imagine a container, and let's imagine that it has liquid filled in it. So let's imagine you have something like this. Okay. Now, what you're trying to do is essentially, let's try and consider an element in this. Okay, so let's consider, for the sake of simplicity, Let's consider an element which is something like this. Okay, so let's consider a cylindrical element like this. Let's consider a section of water or the liquid which is filled in this imaginary cylindrical boundary. So I'm making imaginary cylindrical boundaries and I'm going to focus only on the liquid which is filled in this part. Okay, doesn't work here. Okay. So let's focus only on this water, the water contained in here or the liquid contained in here. Okay, so if I make the FBD of this, if I make the FBD of this, what do I see? What are the forces acting on it? So let's say there would be some pressure acting downward from here. Let's say there is a pressure P1 which is acting downward. Okay, okay. Screen got hung. Yeah, I think it's back now. So let's imagine from the upper surface it is feeling a pressure P1 downward. And let's imagine from the lower surface it is feeling another pressure P2 upwards. Okay. So and of course due to the surrounding sides, it will feel some pressure, but I am only focusing on the y direction forces. Okay. Those forces would be horizontal because as I said, the force is always perpendicular to the surface, right? So side boundaries would be feeling some kind of forces, but I'm not really bothered about them because they are all horizontal. The only vertical forces or due to the surrounding liquid are going to come from the upper surface and the lower surface of the cylinder. Now you will have another force acting on this, which would be the force of gravity, right? There would be some mg, where m is the mass of the liquid contained in this container, right? In this section. So now let's imagine that our hypothetical cylinder that I considered so has an area of cross section A. So let's imagine this area of cross section is A and the height of my cylinder is h. Okay, so here is this area, here is this area. The area of cross section of our cylinder is A and the height is h. So I am considering only the liquid contained in this hypothetical cylindrical area. Okay. So now I can say if we consider the liquid contained in the imaginary cylindrical surface. So what you realize is that this element or this liquid is in equilibrium because overall you don't see the liquid moving up or down, right? So I can say the liquid is in static equilibrium for the container at rest. So if as long as the container is at rest, okay, so I can say that the entire liquid contained in this cylindrical section is in static equilibrium. Now, if this is in static equilibrium, then the net force on acting on it must be zero, right? So I can say therefore the net external force sorry acting it must be zero. correct? So if I only focus on the y direction, so what are the external forces that this segment can feel? Okay, external forces would be of two kinds. So it will be force due to the surrounding liquid because it is in contact with the surrounding liquid. Surrounding liquid is touching it, so there will be force due to the surrounding liquid. Correct. So think about this. Now it is not in contact with any other thing. Okay, it is only touching the surrounding liquid. So the only contact force can be applied by the surrounding liquid plus there can be force due to gravity. So the only non-contact force it will feel is the force due to gravity. So these are the two kinds of external forces that it is feeling, right? So if it is feeling these two kinds of external forces, and if it is in equilibrium, so the net forces must be cancelling each other out. Okay, so I can say for equilibrium in a y direction. So let's imagine only the equation for equilibrium in a y direction. So let's see the forces that are acting again. Let's focus on here. So you had one downward force that would be due to this pressure. Okay, so one downward force coming because of this pressure. One downward force coming because of this mg, and one upward force coming because of this P2. Correct. Can I say that the net downward force must be getting balanced by the net upward force, and that is why the liquid is in equilibrium. Correct. So I can write that what is the downward force exerted by this liquid because of this pressure. If the pressure here is P1, okay, the downward force would be P1 times A, and similarly the upward force here would be P2 times A. Okay, and hence I can say in a y direction or equilibrium in y direction, what I can say is that P1A plus mg will be equal to P2A. Correct? Okay, I hope you guys are following this. So because of that, now I can say P2 minus P1 times A equals mg, and mg would be A times H, that is the volume, times rho times G. Correct. So what we realize is that a delta P equals a rho H. This is our expression. That whenever you come down in a liquid, whenever you move in the direction y direction by a distance h, the pressure always increases by rho gh. This is your proof. Okay. Now, how do I define the absolute pressure? So I can define the change in pressure. Okay. So change in pressure I know. So for absolute pressure, what I will realize is let's again go back to the liquid and let's consider a very small element at the top. So let's do that. Consider an element here at the top. Now, for the equilibrium of this element, this is an element of negligible thickness. Okay, imagine an element of negligible thickness. Okay, so what you realize is that it is feeling an atmospheric pressure P naught, and it is feeling a pressure of P surface, which is the surface pressure of the liquid. Okay, the liquid at this, the pressure at the surface of the liquid. So for again equilibrium of this element, because this element has negligible height, so negligible mg. So I can say from here Ps, P at the surface must be equal to P naught, which is the atmospheric pressure. Okay, I can say, let's write that here. Also, for the equilibrium of an element on the surface, what I'll conclude is P at the surface of the liquid must be equal to P naught. It must be equal to the atmospheric pressure, and that is why the absolute pressure P at any depth h would be equal to P naught plus rho g. Okay, and this is the formula that you need to remember. Okay, and this is the entire proof of this. Okay, I hope you guys followed it. Okay, let me know again if you have any worry about this. Go through it. Go through it. Okay, and let's see. First, what we are doing is we are considering an element like this. Okay, so we are considering an imaginary element contained in a cylindrical, an element of the liquid contained in an imaginary cylindrical surface. Okay, and we are saying this appears to be in equilibrium. If this appears to be in equilibrium, then the net force acting on it in the y direction must be zero, and the net force acting on it in the y direction and the x direction both would be zero. But in the y direction, what you have is the force exerted by the pressure of the liquid above it, the force exerted by the pressure of the liquid below it, and the force of gravity. After the equilibrium, these three forces must balance each other out. So I can say that P1 times A plus mg must be equal to P2 times A. Okay, and then I'm relating this. So I can say P2 minus P1 would be equal to rho GH, and what you realize is delta P is rho GH. Okay. Now, interestingly, this has been asked in mains, I think, or in advance, I don't remember. If you took a liquid in space, then what would be the pressure difference across a height h? It would be zero. It is the force of gravity that is causing the pressure difference. Okay. If the force of gravity was not there, then you would not have had a difference in pressure. A liquid would have actually exerted uniform pressure at all points of the volume. Okay, everywhere, anywhere you would have gone, the pressure due to the liquid would have been uniform if G was not there. It is the force of gravity that is causing the variation in temperature, so you need to remember that. Very, very important. Okay. Now, with the help of another logic, I could also figure out that the surface pressure was equal to the atmospheric pressure, and hence now the pressure at any depth h can be written as P naught, which is the external pressure on the atmospheric pressure. Usually, if the your container is open, plus a rho gh. Okay, so I hope that is clear to all. So if you have any objection regarding this derivation, you can let me know. So this is the proof of that equation. Okay. So here. Now again we have been considering a liquid that has no other external forces acting. So I said the container is supposed to be at rest. So this is a static thing. Okay, this is a static relation. Okay, this is valid for fluids at rest. Yeah, as said here. Okay, if there were other forces also, then you could have had different kind of variation of pressure. Okay, then the pressure variation would not have been limited to this. Okay, we will talk about that again also. So if that is true, now we can talk about the variation in pressure in an accelerated vessel. Okay. So suppose now a vessel was accelerating also. So how do I do that? So what I can do is let's say that there is some acceleration a vector of the vessel. There's some acceleration a vector of the vessel. So in the reference frame of the container, now how will I see the liquid? In the reference frame of the container, again the liquid would be appearing to be in equilibrium and at rest, right? So I can say, let the container have an acceleration of a vector, and let's take a very generic case. Now let's take a very generic case, and let's imagine that I have a 3D expression ax I cap plus ay j cap plus az k cap by SI acceleration area. Okay. Now in the reference frame of the container, in the reference frame of the container, in the reference frame of the container, the liquid appears in equilibrium. Okay. Now, using that fact, I can decode the variation of pressure. Okay. Right. So what we are going to do is we are going to consider different elements and the pressure across those elements. Okay. Yeah. Let's add another page and talk about this in detail. Okay. So now let's consider again one last time that you have this vessel. Okay, and you have this liquid. Now, in the reference frame of the container, you would find a pseudo force acting on all molecules of the liquid. Correct? Can I say that? So I can say in the reference frame, in the reference frame of the container, every molecule of the liquid will experience a pseudo force, right? And how much is the pseudo force? I know that it would be minus dm times a vector, where dm is the mass of the liquid element. Okay, or the molecule. Okay, so now what we will do is let's draw ourselves some axes. Okay, and let's consider the variation of pressure along different axes. Let's divide this to again y, x, and z. Okay. Now let's consider a small element. Now consider a small element. Okay. Now consider a very small element of the liquid, and let's try and figure out the changes in pressure across it. So if I consider a small element like this, so imagine this is a small cube of a liquid that I am considering. Okay, so here this surface and like this. Now, if I talk about the x direction, in the x direction, what are the forces? Okay, so imagine there would be a pressure in this direction. There would be a pressure in this direction. Let's call this P. Let's call this P dash. Let's say this is the x thickness, and you will obviously in the x direction you will have a pseudo force to be opposite to the external acceleration, right? And how much will that be? There would be a dm ax, correct? So the element that I'm considering is, let's imagine a cube. Let's imagine or a cube or let's say a simple element of thickness of dx. This side is dy. This is dz. So small element which has dx, dy, and dz dimensions. Okay. So can I say for equilibrium in x direction? For equilibrium in x direction, you realize what is the area of cross section? It would be dy times dz, right? And this area of cross section. This area of cross section is, this was dy, this was dz. So this area of cross section is dy times dz. Correct. So now for equilibrium in the x direction, what I can say is that from here P1 dash is exerting a force, P dash is exerting force, from here P is exerting force, and the acceleration, and then there is a pseudo force. Okay, there is a pseudo force. Again, the pseudo force is in that direction because I am assuming the actual acceleration in the x direction is like this, ax. So the pseudo force is acting in the opposite direction like this. And all these three forces must be balancing each other out. Okay, so what I'll say is for x equilibrium of or x direction equilibrium of element considered, what we will see is we will see that P dash A dash times P A instead I can write as dy z, okay, would be equal to P times dy dz plus dm times. The dm is the small mass contained in that element. Okay. So I hope you can see that this is the element that I was considering. Okay, I am considering an element like this. Okay, imagine this being dx, this side being dy, and this side being dz. That is the element that I am considering. So for x direction forces are acting on this element and this element, right? And the areas of this would be dy into dz. Okay, Maharana study classes से सर मेरा मैकेनिक्स वीक है क्या करूं? Okay, तो यार पढ़ो कॉन्सेप्ट्स रिवाइज करो एंड प्रैक्टिस करो और क्या हो सकता है? कोई भी चीज वीक है तो उसे स्ट्रॉन्ग करना पड़ेगा यार, मेहनत करनी पड़ेगी और कोई तरीका ही नहीं होता. ओके, सो what again what I can write is dm, I can write p dash dy dz plus p dy dz times mass can be written as again rho times the volume, which is dx dy dz dx. Okay, correct. So now you realize these and these will get cancelled, and what you have is p dash minus p to be equal to rho ax. You realize this dpx. I can write this as dpx. Change in pressure in the x direction is equal to rho a of x times. Okay, got it. So when you move in x direction, if you have a pseudo force acting in this direction, then in this direction the pressure would increase, and the increase in pressure would be like this. Similarly, I can say what you can say is dpy, the change in pressure in y would be rho ay dy and dpz equal to rho az dz. Okay, this is how you find the pressure variation anywhere. Now you can integrate this. You can integrate this and find the delta p's. Okay, I hope you got the logic of this. So because of the pseudo force, now the pressure in x and y can also vary, and z can also vary. See, as I told you, why was the pressure varying in the y direction originally? Originally, it was varying only because of the acceleration due to gravity or the force of gravity. In this direction, in this kind of a case, you realize the pressure, when you would have looked at this closely, what you would have realized is that in the x direction there would have been no variation of pressure. The reason for that is for equilibrium. For equilibrium, you would have realized that the force in this direction due to this pressure and force in this direction due to this pressure would always have to cancel each other out. So the pressure in the x direction does not vary. There is no variation of pressure in the x direction. Similarly, there would be no variation of pressure in the z direction. If the only force, external force acting is the force of gravity, which is acting downward, then the only variation in pressure will exist in the vertical direction. Okay, please remember that. Now, when the vessel was accelerated, then in the reference frame of the container, you could have had pseudo forces acting in all directions x, y, and z, right? So when you feel a force in x direction, then the pressure in x direction will also start to vary. If you feel a force in z direction, then the pressure in z direction will also start to vary, and that variation can be determined using these equations. So you can either use this, or use this, or use this. Okay. These equations. Hi ARJ, how are you? These equations can be used to determine the variation in pressure in the x, y, and z directions. Okay. All right. Moving forward. Now, let me tell you something, another interesting thing. How about the shape of the free surface? How about the shape of the free? Now, you realize is that since by definition liquids cannot withstand tangential stress, its free surface always aligns itself perpendicular to the direction of the net force. Okay, imagine what is happening. Imagine what is happening. When I have water in this glass, how is the free surface oriented? It is oriented like this, right? Now, when I tilt this, what happens is that liquid from here comes and flows here, and this is still horizontal. This is still horizontal. No matter how much I tilt this, you realize the free surface always remains horizontal. Okay, you can notice that now. If I have a straight finger, it doesn't matter how I am moving this, the water level always remains horizontal. When do you think JEE Advanced will be? Okay, so JEE, let's say mains, you have in Feb, March, April, May. Then in June, so May, if you have your final JEE mains, so in June, most probably you will have your result of JEE mains. So in July, you can expect your JEE advance in June or July. Okay, ARJ, that is what you can expect. That is what I think. Usually they start a new semester in IITs, at least I remember the new semester gets started in August, right? So in August they would want to, if they want to target an August start to the semester, then they should be taking the advance towards probably end of June, so that you can have results and counseling within July itself. Okay, so June end may be a good time to have JEE advance. Okay, now so what I told you was that imagine if this shape did not change. हाँ, अगर ऐसा नहीं होता तो क्या होता? So let's imagine that this was the liquid and you tilted the container. हाँ, आपने container को ऐसे कर दिया. And let's imagine if the liquid does not tilt. Liquid is like this. Now what you realize is now shear stress. Shear stress is a stress provided by a force acting along the surface, right? So you realize in this case, the force of gravity of this element. So if you take any element, this would have felt a force of gravity in two directions, right? Any element of the surface would have felt the force of gravity in two directions. One in here, so I can have a component here and a component here, right? So that component of the force of gravity along the surface would have provided a tangential stress or a shear stress. Now that would have essentially caused this to flow in this direction, and hence you should have seen the level rise here and the level drop here until it would have become like this. The moment your surface aligns itself perpendicular to the external force, now you don't have any tangential or shear stress, and that is where the equilibrium would be found. Okay, now even if you're accelerating a vessel, even if you're accelerating the container, In the reference frame of the container, again, the liquid will try to do the same thing. It will always align itself perpendicular to the G effective. Even for an accelerated container, the liquid's free surface times itself perpendicular to G effect. So if you want to find the shape of the free surface, then you can find the G effective, and you will know that the free surface will always be perpendicular to that. So Sachin Pandey says, "Sir, till now I just studied NCRT. Want to crack mains Feb? What can I do?" Okay, so if you are thorough with your NCRT, what you can do is you can try to solve some problems from HCRMA and definitely go for the previous year questions. So I think you have another, let's say, 2 months at least, right? So for 2 months you can try the previous year questions plus try to solve your HCV. Okay, maybe not in 2 months, but let's say, yeah, you do require more time. But definitely do this. Definitely do this. This you should be able to do. Plus, if you have extra time, then try to practice from HCRMA. Okay, so that is what you can do. So try and build another approach. So the difference, Sa- Sachin, Sachin, the difference is that you realize the concepts are essentially the same. NCRT, the level of application or the idea or the complexity of the problem is lower, and then for mains it goes higher, okay, and then in advanced it goes even higher. So it's not the concepts that are getting more tough, right? The concepts are the same, but you will require a more in-depth understanding of those concepts. So you should have been thorough with the concept, and then more and more practice. If you do, then your concepts will become clearer. Okay, so that is what you can do. You can try solving this first, and then if you have time, try to solve some questions from HCV also. Okay, let's hope you can do a decent enough job with that in JEE Mains. Now the problem is, Sachin, the JEE again is a competitive exam, so वो एक issue आ जाता है. Now even if you might do everything, but because it is a competitive exam and because unlike you, maybe others have spent more time on practicing, so you may still not do as well in the competition, but don't feel bad about that. Okay. Hi Lakshmi, how are you? All right. All right, so this is where I would like to wrap up today's session because we are almost running out of time. So we will discuss about this. We will continue this discussion of the shape of free surface in the next class. So I've told you the idea because a liquid cannot withstand any shear stress. So that is why you realize the surface will always reach equilibrium only when it is perpendicular to the external force. So that no component of external force can act as a shear stress. Right. So again, we will go about this discussion in detail in the next class. Okay, those of you who joined late, please go through the entire lecture. We have discussed some really interesting points about fluids. I've tried to give a lot of cool proofs also. Okay, all right. So before I wrap up today's session, let me remind you that if you haven't gotten your Unacademy subscriptions and if you're planning to, then this is how you do it. You can go to the plus section of the app, select your goal as IIT and click on that get subscription button. All right. Now, when you do that, you'll be redirected to the payment page where do not forget to use this code RD Live. So you will have a box which will say, do you have a code? That is where you can put this code, get a 10% off on all your subscription fees. Okay. And now you can choose from Plus and the iconic subscriptions. Also, when you click on proceed to pay, you can select a no cost EMI option which suits you and which doesn't let you feel the burden of the payment. Okay. as I was saying, now you can also choose from the iconic subscription. So iconic subscription is something which will take your JEE preparation to the next level by allotting you personal coaches. So students who find you know that they study better under more personal guidance can go for this. And of course, you get all these extra features also apart from all the features that you unlock from the plus. Okay. Now you can also go for a combo subscription for your JEE and board preparation. So if you want your complete one-stop solution for your entire board preparation plus your JEE preparation, then you can go for these combo subscriptions. So there are four kinds of combos currently available. So you can have an iconic subscription for JEE and plus subscription for your boards. Then you can have iconic subscriptions for all three, and these combos start at these prices. Okay, are available at these prices. Then you can have a combo of all the plus subscription or the plus for IT and iconic for your boards. Okay, so whatever your preference be, so accordingly you can choose a right combo for you. Now again, don't forget to take part in the Unacademy Combat. This is a great platform for you to judge your understanding of concepts, judge your standing amongst your peers, how you're doing in with respect to the competition, and if you do well, then you can have a chance of winning really cool rewards and prizes. Okay, so including an academy plus subscriptions. Okay, and other cool prizes. All right. So the next event is going to happen live on the 17th January. You can enroll in for that using this code RD Live. Okay, and I'll definitely wish you luck. Everybody going in for RD Live would I hope cracks it up. Okay, so that is what you can do. So this will be not only a good opportunity to test your knowledge and your understanding, but also a great chance to win yourself some really cool prizes. All right, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using that link so that you're receiving all the notifications of every session and lecture happening here on this channel. Okay. Next, before I wrap up, let me remind you that this is my code RD Live. So if you like my lectures, if you would like to enroll in my plus courses, if you would like me to guide through your IIT journey, then you can get your subscription using this code. This will also get you a 10% off. All right, so I will see you next where we will carry forward this discussion day after tomorrow. Till then, you guys take care of yourselves and keep studying hard.